All right, so as we look at these graphs, the key to any graph problem is to first identify what they gave you. So as you read this and you see that this is a graph of f prime, I would strongly suggest you highlighting it, putting a box around it, writing f prime again somewhere, because the chances of you making a mistake, that's where you're going to make your mistake. What did they give you? This is f prime of x. So if that gets locked in your brain, you will be way better off. Okay. And so a couple of these questions are really easy. Like letter B just asked me, when is f prime of x less than 0? And letter D is, when is f prime of x decreasing? They told me f prime and they asked me a question about f prime. That's easy. Okay. So when is f prime less than 0? Max McCain, when is f prime less than 0? 0 to 6. That's easy. Okay. Because it's very simple. It is just, when is it below the x-axis? So from 0 to 6, I'm below the x-axis. Letter D says, when is f prime decreasing? This is f prime. What does decreasing mean? Negative slope. Tell me now, or at the beginning, do I have negative slope? Yeah, I'm decreasing. Tell me now when I stop decreasing. Right there. From there to there. So from there until 3. So from -4 until 3, I'm decreasing. Technically, it'd be parentheses because I'm talking about f prime decreasing. Don't worry about it. It's not that big a deal. Those two questions are easy because it's in terms of what they asked for. Okay. When it gets a little bit tougher is the questions when they ask for something that is not given. So for example, this one is saying, when is f decreasing? So I need to interpret that. What does that mean? F is decreasing means f prime of x is blank. If f is decreasing, it means f prime is what? Negative. Because f decreasing means it has negative slope, and f prime is slope. So it means f prime is negative. Tell me now when I start being negative. Now, so from right there, tell me when I stop being negative. Yeah. Oh, it's the same thing as the last one. It's 0 to 6. Because negative just means when I'm below the x-axis. So from 0 to 6. That is when f is going to be decreasing because f prime is negative. Next question. When the slope of f of x is positive. If the slope of f of x is positive, that means f prime of x is blank. F prime is positive because the slope of f of x is what f prime means. F prime means the slope of f of x. So f prime is positive. Okay, so tell me when f prime is positive. Right here, is f prime positive? Yeah, because it's above the x-axis. Tell me when I stop being positive. There. So from -4 to 0. F is concave up. If f is concave up, all right, now that's a different story. When we think about f being concave up, what derivative do we normally think about when we talk about concave up? Second derivative. F double prime is what if I'm concave up? Positive, which is great. I'm glad that we know that, but that's not what they gave me. They gave me f prime. So f is concave up, means f double prime is positive, but what does it mean about f prime? Because that's what I'm given. F prime is increasing, and here's how we can do that. If I want f double prime to be positive, I want to be looking at the slope to talk about f double prime. If I'm talking about f prime and I want to look at its derivative, I'm looking at the slope. So if I want f double prime to be positive, I want f prime to have positive slope, which means increasing. So tell me when I am increasing here. Now, yeah, so none of that from there to there, from 3 until 6, f is concave up. That is the key to everything we do, okay? Understanding how to understand what they gave me and what are they asking for. If you can build those connections, you're going to do great. All right, this chart that I just gave you is going to be your best friend, okay? You already probably know a lot of it already, but if what we just went through wasn't locked into your brain already, you're going to want to memorize this chart, okay? This chart is what's going to allow you to be good at these problems or not. All right, so for a few minutes here, okay, I want you to talk with your neighbor. If I were to ask you, when is f increasing, what does that mean you're looking for on an f prime graph? It's basically exactly what we just did. Okay, try to work through that list there and try to fill in what you're looking for. If you're not confident, write it in pencil or write it really small or just talk about it, but we'll fill it in here in about 1 minute. Okay, talk to each other, try to figure out what goes in each blank. Increasing. Here we go. If we're talking about a function being increasing, Talon, what are you looking for on an f prime graph if you want f to be increasing? F prime is positive. Because again, we're thinking about positive slope. Increasing means a graph is going up. F prime means the slope. It means it has positive slope. Okay, so that means positive. So, Macy, what about decreasing? What are you looking for on F prime if you're decreasing? F prime is negative. We just did that in Bell work. Okay, those two things should be pretty good. A relative maximum. If F has a maximum, think that's what a maximum is. What is going to be happening with F prime if I have a maximum? Ken? It is going to change, or F prime changes from positive to negative. We just talked, that is a maximum right there. Positive slope to negative slope. F prime is changing from positive to negative. That is what we're looking for. So if that's true there, Isabel, when's a relative minimum going to happen? When F prime changes from, that says as a G, that's the worst G I've ever seen. Changes from negative to positive. Good, we got to have those things locked down. Okay, the next category is concavity. And so now we're talking about not only F prime, but F double prime as well. If I'm concave up, Renee, what's going to be true about F double prime if I am concave up? F double prime is positive. Good. F double prime is positive. So concave down obviously is negative. What about an inflection point? What is happening on F double prime if you have an inflection point? Max? The signs change. That's key. It's not just zero, but it has to change signs. F double prime changes signs. That's what we're looking for a point of inflection. And to me, these are the three hardest squares on here. I think the rest of those, we get those locked down probably already. But these three right here are the three that you're going to struggle with a little bit more. F is concave up. Means F double prime is positive. But what does that mean is happening with on F prime? Lulu? F prime is increasing. It is increasing because to go from F prime to F double prime, you're thinking about slope. So if I want F double prime to be positive, I want F prime to have positive slope. So positive slope means it's increasing. So that means if I'm concave down, F prime needs to be decreasing. And then we get to the last one, which I think is the toughest one. Okay, if you have an inflection point. Okay, remember what an inflection point is. That's a graph where you change from concave up to concave down. F double prime changes signs. But what has to be true about F prime? The slope changes signs. Because I want it to change signs and I want to look at its derivative, that means I'm looking at the slope. So the slope changes signs. Okay, you can write that. The slope changes signs. That's great. But there's an even easier way to say that. What happens when your slope changes signs? Ready? My slope is positive. My slope is now my slope is negative. What did happen? And then I went from negative slope to positive slope. Slope changes signs, or in other words, you have relative extrema. Relative because we're not including endpoints, and endpoints are not included when we talk about points of inflection, but it has relative extrema. You're looking for where it has maximums and minimums. If you can memorize that chart and understand those connections, then this week is easy, okay? If you can't, then you're going to struggle a little bit, but that is the key to this success here is that chart. Questions with anything so far? All right, let's go to the backside. All right. I want to change this one here because I don't like that it did this. But where it says f double prime is equal to 0, so for letter B on each one of them, okay, or letter A on the last one, change that to f has a point of inflection. F has POI. F has POI. It just makes more sense to me. F has POI. All right. Let's do this. So this is a graph. My first graph up here is F. My next graph, I've got an F prime graph, and then my last graph, I've got an F double prime graph, and we're just going to answer different questions. Okay, so again, we look at this graph that we have here. The first thing we're going to do is identify what I have. This is an F graph. This is f of x. And so I need to answer questions based on f of x. The first question is, where is f prime going to be equal to 0? What am I looking for on this f graph for when f prime is 0? The slope. Show me with your fingers. How many places is f prime equal to 0? Show me with your fingers. How many places is f prime equal to 0? 3. X is equal to -2, 0, and 2. Right there the slope is 0. Right there the slope is 0. Right there the slope is 0. Good. Where the next one, letter B, says, where does f have a point of inflection? This is the hardest one on here by far. Okay, and it's not that deep. Point of inflection. What is happening on an F graph if you have a point of inflection? Concave up to concave down. The front side of that chart doesn't really even tell you anything, but it's where you change concavity. Okay, so if I were to start on this graph, okay, remember concavity is how you bend. So right here, at the very beginning, am I bending up or down, would you say? Up. Tell me now when I stop bending up. Like there. Okay, because from there on, now my graph is starting to do this. Now my graph is down like a frown, down like a frown, down like a frown, down like a frown. Okay, so I would say right here, there is a point of inflection. And if you're struggling to see that, I'm okay with it. It's hard. Okay, they'd never ask you on an F graph to find a point of inflection because it's hard to see. But there it is. Okay, I would say it's at x is equal to -3.5. When would you say our next point of inflection is? Show me with your fingers. Where do you think your next point of inflection is? I would agree with -1 because I'm concave down, concave down, concave down, concave down. And then right here, I start to bend upwards. So -1 right there is when I change concavity. So -3.5, -1. Show me with your fingers. Where do you think the next point of inflection is? The next one, I'm concave up, concave up, concave up, concave up. And then right there, I switch to being concave down. So right there at about 1, I have a point of inflection. And then my last one, what do you think on that one? Yeah, like 3.5 again. Okay, 3.5 is probably in there. And if you don't see that perfectly, I'm fine with it. That's the toughest question on this paper. Everybody go to that point? Now we're talking about increasing. Talk with your neighbor. How many different intervals here are you increasing? Show me with your fingers. How many intervals are you increasing? 2. This is a graph of f, and I'm just asking you, when is f increasing? That means when is it going up? So we're going to start. Let's act like this graph is continuous. So we'll go from -infinity until -2. I'm going up this whole time. I'm going up, going up, going up, going up, going up, and then I start going down. And then right here at 0, I'm going up, going up, going up, going up, and then I'm going down. So from 0 until 2. Write the intervals of decreasing. Go. Luke, when do you think I'm decreasing here? -2 to 0. Good, I agree with that. I'm going down during that time period. I'm going decreasing that whole time. And when else? 2 to infinity and beyond. Yep, good. I'm decreasing. Good. We've got that. Now we're to the last one, and probably the one that makes a little bit more thinking. Concave up versus concave down. Here at the beginning, what would you say? Are we concave up or concave down here at the start? Up. Tell me now when I stop. Right there. That's why we made those points of inflection. The points of inflection are when I change concavity. So I'm concave up here from negative infinity, according to this, to negative 3.5. When we talk about concavity, it's always in parentheses. That's an answer. And where else am I concave up? Alana, where else am I concave up? So remember, concavity during the whole thing. What would you say is true about the concavity right here? Am I concave up or down? I'm up right there too, right? Because it's going to form a cup. And so you got the right idea, but at that whole time period in between, from -1 to 1, because points of inflection are where we changed concavity. So I have to go from one point of inflection to the next if you're doing that. So here we're going from -1 until 1. Jalen, when else am I concave up? Good. That last part right there, I'm starting to bend up. It's not a huge bend, but it's still a bend. So from 3.5 to infinity. And again, that is not a question they ask very much. They are not going to say, look at this F graph, tell me concavity. We'll see that more as we go on. So concave down are the other parts. Concave down in between there and in between there. So I'm concave down from -3.5 to -2 and from 2 to 3.5. Questions so far. We looked at F and we wrote about F. Try the next one. Okay, with your neighbor there, try to talk yourself through those 6 things, see what you can do. What is this a graph of? This is an F prime graph, so make sure you're labeling that. Think about what you're given. Here we go. Let's look at it. This is a graph of F prime. Did I not have -1 and 1? Where? I know, but which question? Oh, for letter F? I'm not concave down between -1 and 1. I'm up like a cup. Oh yeah, I wrote 2. Thank you. Sorry. I wrote the wrong number. Thank you. That is -1 to 1. I don't know where I got 2 from. My bad. Thank you. All right. When is F prime equal to 0? So this is a graph of F prime. Max H, when is F prime equal to 0? X equals -2, 0, and 2. This is F prime. When is it 0? When I touch the x-axis. Okay. When does F have a point of inflection? And you might have to flip back and forth on your chart here a little bit. Show me with your fingers how many points of inflection does this graph have? 4. There are 4. Renee, what are you looking for here to find a point of inflection? The extrema. This is an F prime graph to talk about points of inflection. She's looking at extrema. And so what's going to happen right there at -3.5, right there at -1, right there at +1, and right there at +3.5. When is F increasing? What am I looking for on this? Well, what am I looking for on this F prime graph to talk about where F is increasing? Where F prime is positive. Okay. What about when you're decreasing? Where F prime is negative. And so hopefully you noticed that the answers to this were the same thing up above. Okay. I'm increasing from -infinity to -2 because F prime is positive. And from 0 to 2 because F prime, this is a graph of F prime. Sorry, I meant to highlight. It's going to hate me. F prime is positive. I'm above the x-axis. That's what we're looking for here. When am I above the x-axis? Okay. When is it decreasing? When I'm below the x-axis. When F prime is negative. So right there and right there. That is when F is decreasing because F prime is negative. They mean the same thing. Concave up. Show me with your fingers. How many different intervals is F going to be concave up? 3. Andrew, what am I looking for on this F prime graph to talk about when F is concave up? When it's increasing. when f prime is increasing. That's what we talked about on the last page. So I'm increasing. That's f prime increasing. That's f prime increasing. That's f prime increasing. Or in other words, it is these answers right here. Because it's the same graph. This is the derivative graph. I just graphed you the derivative. That's all we're doing here. Okay? But it answers the same questions. When am I concave down? You are concave down when f prime is decreasing. Boom. From -3.5 to -1. And boom. From -1, from 1 to 3.5. Does it make sense, the connections we're trying to make here? We're trying to see those things in real life. When we wrote it in our chart, when we said we are concave down when f prime is decreasing, yeah, it is. We can see it. Try the last one. F double prime. Answer those questions. Go. F has a point of inflection. What needs to happen on F double prime for F to have a point of inflection? F double prime just needs to change signs. Inflection point is when F double prime changes signs. We're right here. Okay, on that guy. F double prime changes signs. So, Michael, when do you have a point of inflection here? At -3.5. Where else? -1. Where else? 1 and 3.5. It's exactly the same question we answered on B. Exactly the same question we answered on that B. It's the same thing. You're looking at different things, but it's still a point of inflection. When am I concave up? Bottom out, what am I looking on F double prime for F to be concave up? Positive. Yeah. F double prime is positive. So when am I concave up? Anytime I'm positive. And that's the same question we answered up above. F double prime is positive. From here to here. Okay, from here to here. From here to here. From there to there. I'm positive because I'm above the x-axis. Oh yeah, it's those three answers right there. Okay, same thing on when am I concave down. It's the other spots. That's what we're trying to work through. Makes sense on how these things are connecting. All right, look at that activity that I passed out to you. Okay, a little bit different. If you've got colored pencils or markers or something, it might be helpful to you. If not, I will bring you. I have a couple that you can borrow too. Okay, you can just scan that link with your phone and go to that website. Okay, if you don't have a device, you can use your neighbor's device once you figure one out, but it's easier if you have your own device. 3. Here's how this works. Scan that link. You're going to get a graph like this. Okay, on this graph, there are some things. So you want to hold your phone sideways because it's going to be easier to see and try to zoom in as much on that graph as you can. But this is an F graph. Okay, it's got these 4 movable points. Okay, so I can move these points around and it will give me different graphs based on how I move. Okay, this slider right here can make it more or less complicated. Okay, I want you to have at least 3, if not 4. So I need to be on the last 2. So I don't care which one you pick. Okay, but you're making one of those. Okay, there's some buttons up here. Up here you can turn on inflection points. And you can see, oh yeah, that's where it changes concavity. So if you're not real clear on that, you can move it around and being like, oh yeah, that makes sense that that's where an inflection point would happen. Okay, what you want to do is I want you to make a graph. Okay, you get to move around the points. You get to move it however you want, but you're trying to make a graph. To make it easy on yourself, try to make the maximum happen at a x value, like someplace on the graph. So like right there, it looks like it's happening right at that spot. Okay, try to make it so that your inflection point happens on an x value. And if you got to cheat a little bit, that's fine. Okay, if you got to cheat a little bit here to make the minimum on it, great, that's fine, but we're doing that. So you're going to make a graph. Then the cool thing about this program is you've got F prime and F double prime. Okay, so over here I can turn on F prime. And then based on whatever graph I made, it's going to show you what F prime looks like. So if I move this around, you can see that F prime changes. Okay, and then once you've looked at that for a second, then you could turn on F double prime. And know that F double prime is kind of boring. Okay, it's going to be a straight line for this graph. Okay, and it doesn't even look like it has much bend to it. But there it is. So what I want you to do on your paper is I want you to graph the original graph, the derivative, and the second derivative as best you can. It doesn't have to be perfect, but you're trying to match it up. Then once you've graphed that, you're going to answer these questions down below based on that. Okay. In these first columns, you are putting the numbers. Okay. Based off of your graph, what numbers go in those spots. And then in the other column where it says, when this happens, F prime and F double prime, this is the reasons. What are you looking for on that F graph to determine those things? Okay. You're going to be increasing because F prime is blank or F double prime is whatever. Everybody kind of understand what you're doing? On right now.